Hello. So welcome to the part 4. We have additional part. So I finished the lecture. So this part is just to do some revisions on what we have learned based on previous final year exam questions on FM, focusing on part 2, which is the FM modulation and demodulation. Okay, I've shown all these questions before I started the lecture. So at the end of the lecture, let's see if we can answer these questions. We should be able to answer the questions because we have already listened the lecture. Listen to the lecture. So we should be able to answer the questions. Okay, let's go through the questions. So this question is from year 2014-15, semester 1. So FM has found what application in the area of radio broadcasting to replace the early AM radio. First, provide one advantage and disadvantage using FM instead of AM in this context. So this one we have already addressed when I compare, do the comparison between FM and AM. Okay, if you remember, the FM has the advantage of large bandwidth, but its advantage is that noise immunity. So main drawback of using stereo. So drawback is another word for disadvantage. Okay. What is the disadvantage? Okay, we know the advantage of FM stereo from our third lecture. Yeah, it produces more natural, high quality audio signal, but it has problem. It's more complicated lah. The drawback more complicated and uses large bandwidth. Yeah. So, and then finally, the operation of FM stereo transmitter. Okay, so this one you can refer to the block diagram that we discussed. We have all the three components. Remember, the double sideband part, the pilot part, and also the L-R part. Okay, and don't forget the pre-emphasis in your circuits. So this one refer to block our lecture. Okay, next. Okay, engineer responsible in the design of FM transmitter. Approaches for consultation, operating frequency 104, maximum frequency deviation 75. So you're given all these components. Draw block diagram. So we know that this is a wideband FM, and I've shown you in the solution to example. Okay. So how to sketch our block diagram for wideband FM. So we have already addressed this in our lecture. And engineers suggest adding another FM transmitter that works at 104.1 megahertz. Discuss the possible effects that can occur when both transmitters operate simultaneously. Okay, so we know that our frequency deviation is 75 kilohertz. Okay, so delta F 75. So if we do not consider, okay, so channel bandwidth, so our delta F 75 kilohertz. So 2 delta F is 150 kilohertz. So 104 and 104.1. Okay, so the difference between them is just 104 and 104.1. Okay, so difference between them is just 100 kilohertz. But minimum, if we do not consider guide band, is 150 kilohertz. Okay. So obviously if the difference between them is just 100 kilohertz, let's see. So here 75. 104.05. So we will extend 100. Maximum 104.75. Okay. So in between is 104.05. So this one is from up to 104.075. Obviously, it will cost, extend up to here for the first channel. The next also, okay, like this. So we have this overlapping, right? So possible effects that can occur is interference due to overlapping frequencies between 104 and 104.1. Okay, so let's look at the next. Okay, okay, so this question I have already shown the solution. You can refer to the lecture. Try to understand the lecture, yeah, because almost the same concept you can use to solve the next question. This is also another question on generation of wideband FM. Okay, next. So it's illustrate super heterodyne FM receiver. Okay, to receive frequency band between 1 to 30, intermediate frequency 8 megahertz. So, okay, obviously these values are not based on FM radio broadcasting standards. So the values are other values that used in the exams. So you need to find the local oscillator's frequency. So we know that FLO is FC plus minus FIF. So you need to consider between the minimum FC up to the maximum FC. Yeah? So this is the range of our oscillator's frequency. And from block diagram, describe two methods or principles of demodulating FM signal. Okay, we know that you have direct and indirect, right? Okay, so show here. So your FLO to FC min plus minus FIF, FC max plus minus FIF. Okay, because you need to state the, oops, sorry. The range of oscillators frequencies. Okay. For two methods of FM demodulation, we have the what we have already learned in our lecture, direct and indirect. So this one using discriminator plus envelope detector, and another one indirect using phase lock loop. Okay, so the block diagrams are not that complicated, yeah. So you should be able to draw the block diagrams and explain briefly. Okay, next. Okay, FM has found wide application in the area of radio broadcasting. One advantage and disadvantage of FM. Okay. And then main driver of stereo. Operation of FM stereo. I think I've already shown this. Okay. This one already discussed. Illustrate super heterodyne FM receiver. Clearly state required oscillators frequency. Okay. So actually it's almost very similar to the previous question. It's just that the range of FC is different, but same. Same. Basically, you can just use the same solution. Okay, So that's it for our final year exam discussion. So I believe you should be able to answer them since we have already addressed them in our lectures today. So all the best for your revision. For our first test, this part, the generation and detection of FM signal will not be assessed in first test. It's only the first part, up to from general equation up to power calculation. Okay, so I'll stop here. Okay, see you next week for our new chapter, entirely new chapter on pulse modulation. So let's finish the analog part. Next, we'll move to the digital modulation in chapter 4. Okay, have a nice day. Assalamualaikum and good afternoon.